All right, now let's finish the remaining rules and finish up this packet so you can apply our rules on some multi-step problems that we're going to lead up to. So previously we were doing multiplication and the power rule. Now we're going to get into quotient. And quotient is just basically when we're dividing, okay? So expand it, and then we're going to do the division. So remember, x is our base, the 5 is the exponent. So this lets us know how many factors we have of our numerator. There are 5 factors of x here, and that is all over 3 factors of x. Oops, there's multiplication there. And so to simplify this, we would pretty much just cancel out like terms or like factors. So like these two cancel, 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 and this will leave you with 2 factors of x, which is the condensed from its x to the second power, or x squared. Okay. So if I was showing the expanded of each base and its exponent, it's just 7 factors of x all over, sorry, 2 factors. And hopefully we're trying to get you to see a pattern here. We're going to cancel, and what we have are these cancel. And what we have remaining are 5 right here, factors of x's. So this is x to the 5th power. And so there is a pattern with dividing our exponents to get to the condensed form. So if we look here, we have 5 and 3, and our condensed, our final answer was 2. Here we had 7 and 2, and then our final answer was an exponent of 5. So if you have more than one base, more than one variable, you're going to do the same thing, give out your condensed. So this is 4 factors of x times 6 factors of y all over 2 factors of x times 3 factors of y. Alright, so we're going to cancel our like. Let's do that in red, sorry. So I want these. Why is it not changing color? Let's see. Oh, I don't know. So we have these two cancel, and then we have these y's cancel, leaving me with 2 factors of x's. And let's see if I do it this way. No, it's just not changing. And 3 factors of y. So this is x to the 2nd power, y to the 3rd power. So this is a large, I don't want to do expanded of 100. So I was hoping if you saw, whenever dividing like bases, when you have exponents between them, you're actually subtracting. 5 minus 3 is 2, 7 minus 2 is 5. If I subtract the 4 and 2, that's why I had exponent of 2 here. 6 minus 3 gives me an exponent of 3. So I'm really just taking the exponents and subtracting when we divide. And so this is x to the 97th power. So our rule that we're showing here is whenever I have x as my base and we're dividing same bases, we subtract the exponents. Okay, and so you can just do that mentally and come up with your solution. For example, I'm just subtracting 15 from 5, so this would be x to the 10th power. Okay, here I'm 25 from 10, so this is going to be a y to the 15th power. 24 minus 2, 22, this would be w to the second power. Okay, this ends up being just v to the 1 power 1, which is just v. Here we would have x to the 6th power. And when I have more than one variable, like variables, you're still doing your x's. So 5 minus 2 is 3, so this is x to the 3rd. And then y, 4 minus 2 is 2, so 5 to the 2nd. Okay. So when dividing exponents with the same basis, you subtract the exponent. Now we're just going to expand that with negative exponents. I need you to recognize the same relationship. We're doing division. So this is 3 factors of x's on the top, and then 5 factors of x's on the bottom. We're going to cancel out like terms right here, and notice everything's done on the top. So this actually is reduced to 1 over x to the 2nd power. So if I'm using the quotient rule says we subtract the exponents. So this would be 3 minus 5, which would be x to the negative 2. And we do not leave negative exponents. So what you have to understand, if you have this negative exponent, you change it to a positive by, we say take the reciprocal, but in this case, we're going to put it over 1. Because this is like over 1 here. If I flip it, the 1 goes on the top. So this is, you basically take the reciprocal, change the exponent to a positive. So if it's already a fraction, if it was already on the bottom, it would go to the top. If there is no fraction, then you turn it into a fraction. So I can do my condense, my expand it first. So this is 5 factors of x over 8 factors of x. Run out of room here. And then I'm counting out like terms. And I'm left with 1 over x to the 3rd power. So 5 minus 8 left me x to the negative 3, which is why you wrote that as a positive 1 over x to the 3rd. So you can use your expanded to help you see the relationship, or you can do your quotient rule, which basically says I take the exponents and subtract them. So this is 2 minus 4 here, but then the y is 2 minus 5. So this is x to the negative 2, y to the negative 3. Oops, just ran out of room. I need to fix that. Hold on. X to the negative 2, y to the negative 3. And then we're going to change this to a positive. So this would be 1 over x squared y to the 3rd. Okay. So you can do the math mentally. And so I was going to do this using the quotient rule. This is x to the negative 5, y to the negative 2. Then I would change that to positive by doing the reciprocal. So this is 1 over x to the positive 5, y to the 2. Okay. We don't want to do an expanded for a large number like that. The difference between 37 and 47 is 10. This would end up being x to the 37 minus 47, which is negative 10. We're going to just put that over 1 and make the 10 now, that exponent positive. So the rule when you have a negative exponent is you have to take the reciprocal, flip it basically, and make the exponent positive. Because this technically is over 1. And if I flip that, that's how this x now ends up being in the bottom in the denominator, and the 1 now is on the top. So do your quotient rule, do your subtraction, see what exponent you have. Like this would end up being x to the negative 2. I can't leave it as a negative exponent, so that's just 1 over x to the second power. Here it's already written as a negative exponent of negative 3, so change it positive. You put 1 over x to the third power. Here, this will turn into x to the negative 10. So put 1 over x to the 10th power. Okay. They're both negative, so I'm going to change both to a positive using the reciprocal. So this is x to the 4th, y to the 6th. Now, on number 5 here, I'm going to do the quotient rule. This is saying x to the 4th minus a negative 6, which actually turns to x to the 10th power. Okay, and then here, 2 minus 10 is x to the negative 8, which I turn that to 1 over x to the 8th power. So that is our negative and quotient rule. Our last rule is your zero exponent rule. So I'm going to still kind of help you see what the condense or what happens each time. So if I do 3 factors of x's here over 3 factors of x again, we're going to see each one cancels out. So this actually turns into just 1. So even if I was doing the quotient rule, this is 3 minus 3, which is equal to x to the 0 power. So anything to the 0 power is going to equal to 1. So you can use the expanded form to help you see what the simplified answer is. But basically, every time if I have x to the 5th minus 5, x to the 0, your answer is going to be 1. Anything to the 0 power, okay, is going to turn into 1. This is 1. Even if I have 2 variables, like they would both cancel here, that would cancel. So this is still going to be 1 because you would have x to 0, y to the 0. Even on here, the x's cancel to 0, the y cancels to 0, and the z cancels to 0. It's still going to be the final answer is 1. So 1. Anything to the 0 power equals 1. So they might show it as a quotient where when you subtract them it comes out to be 0. Like this will come out to 0, which means your answer is 1. So this is 1. Now even if you have grouping or parentheses like here, and the exponent of 0, or the exponent is on the outside of that parentheses is 0, this whole term is being raised to the 0 power, which means anything to the 0 power is still going to equal 1. Even if you have an operation, so you're having this plus this, but it's raised to the 0 power, it still equals 1. Alright, so now what I want you to do is we're going to put all, the rules together. Okay, to see if you can recognize what you would have to do to get to your simplified expression. So this is showing multiplication. Hopefully you recognize for this, you would have to add the exponents. So this is x to the 20th. Here, because we have an exponent and then another exponent outside, here you would have to multiply the exponents. It's x to the 24th. Here, we use the power. We have to distribute this power to each term. This is x to the 7th and y to the 7th. Same premise, but we also raise the power to the coefficient. So this is 2 to the third power, x to the third power. The 2 to the third power, we can simplify that to 8, and then you're going to keep your x to the third. Now, if it's a quotient to a power or a division, we do basically the numerator to that power and the denominator to that power. This actually reduces to x to the third over 125. Let's see if we can try and set this one up correctly. So this is 3 to the third power, x to the third power, and the 4 to the third power. We did one like this. Is 27x to the third over 64. Now we're doing what we just kind of covered, the quotient rule, the zero exponent rule, the negative exponent rule. So here we're subtracting. So this is x to the 12 minus 4, which is x to the 8th. Subtracting as well, but doing each variable. So this actually would reduce to x to the 10th, y to the 4th. Now I have a negative exponent. I can't keep that. I have to take the reciprocal and make the exponent positive. This cancels to just 1, because basically it's the same. X to the 0 power, and then anything to the 0 power is 1. Here I'm subtracting to minus 8, which turns in x to the negative 6. You cannot leave it like that. So this final answer is 1 over x to the 6th power. Anything to the 0 power is 1. And back to adding exponents. So we're doing 3 plus 4 plus 10, which is x to the 17th. And here we're multiplying each exponent. X to the third times the 4, y to the second times the 4. So x to the 12th, y to the 8th. All right, so now that you have all the notes, we're going to apply that on the partner and mixed practice, or the partner sheet. So there is a video link on Teams to help you with that. All right, thanks.